Welcome back to Let's Code. Today we are going to take a GitHub organization level webhook and we are going to filter that through a netlify function written in Rust so that it can be displayed in Discord in the Rust Adventure Discord. Now the thing that I'm trying to do here is display a little bit more of the activity that I do inside of Rust Adventure, especially in the GitHub repos, and pull that into Discord so that people can see and keep up to date with changes that are happening to the repos. We have almost 50 repos in the Rust Adventure GitHub organization, which is a lot of code to keep up with. It's a lot of code to manually track. So I want to make sure that when I make changes to those repos, when I create new ones, that people are made aware of them if they are interested in those topics. So what I've done here is I've set up a GitHub organization level webhook that sends a bunch of notifications out via some URL. That URL is a netlify function. So the netlify function is the code that I have here. The netlify function is deployed manually. It's built locally and pushed up by myself. So it's not running in CI or something like that and then getting pushed to netlifys. And whenever I push a new commit from a public or private repo, everything goes here. So why do we have this set up in the first place? Basically, in Rust Adventure, I have not only public repos, but I have private repos. And I don't want all of the commits and the issues for the private repos to also go into the public Discord. So there may be some infrastructure piece I'm working on that I don't quite want to share yet, or some new project that I don't want to share yet. And GitHub doesn't give you a way to filter private repos and public repos on an organization-wide webhook. So we have to write a little bit of code to do that. And while I could have used a tool like if this then that, I decided to write it in Rust because I'm like that. And maybe you are too. And maybe that's why you're watching this video. So let's take a look at what's going on here. We've got a folder here, right? We've got a README with some comments in it. We've got a workspace. So the root cargo toml points to crates/star. So there's one crate in this workspace right now. That's called GitHub to Discord public. There's also basically an empty www for deploy reasons. In the netlify.toml, the publish directory is set to www so that I don't just like publish the source code or whatnot. And then the functions directory points to functions, which is this directory, which is get ignored. And this directory gets all the binaries in it. The just file is basically a replacement for make. So it's just going to be a bunch of cargo commands. In this case, I've chosen to use cargo nightly. So I'm using cargo lambda, first of all, which is one of the tools put out by somebody that works on the AWS Lambda runtime, which is the same runtime Netlify uses. It's basically a wrapper around Cargo Zig build. I don't really use the other features of Cargo Lambda, although you can do other very interesting things with it, like run a emulation server for emulating the API gateway. So Cargo nightly build, we use a nightly unstable option called outdir, called functions, which we need to use the -z unstable options flag to use. This outdir flag is unstable, but it does mean that our binaries get placed in functions without us needing to like go into target, go into debug. Oh no, we forgot which one to use, go into release, go into whatever, and then copy our binaries back out, which is really nice. I don't like having that script in here. So I'm using cargo nightly specifically for that reason. And then the deploy or the deploy prod. So that leaves us with our project. So basically I run just build and it builds. I've already built, so it just, doesn't do anything. And now we can look at our crate. So the GitHub to Discord public crate, we're using Rust Edition 2021. We are using Tokyo as the runtime, Saturday for serialization and deserialization of JSON. The Lambda runtime is the AWS Lambda runtime. We're using 6.1 right now, or 0.6.1. AWS Lambda Events is a community maintained repository of AWS gateway types and other relevant AWS types. And then we're using request to take the request in from GitHub and actually send it out to Discord. So we've got an organization level GitHub webhook going out from GitHub. Anytime we do a bunch of different things, issues, commits, stuff like that, that hits our netlify function. And then we need to send that request effectively after we've checked what we want to check to Discord at some other webhook URL. So in our main.rs, that's where our logic lives, as is pretty typical. In this case, we've got the Tokyo main attribute macro on an async main function. This is kind of boilerplatey. We aren't doing anything in our cold start. This is where you would put any code that would run in the cold start of your Rust function. But we aren't doing anything, so all we do is call the function that we want to call. And this basically just waits and then never really finishes. And then anytime an event comes in, it gives it to our function to process and then waits and then gives it to our function to process and so on. And then we've got func here, which is, our handler, basically, the one that we're running. We'll get to these in a second. So the func, or our handler, I should rename that handler. It takes a Lambda event, which is a new type as of, I think, AWS runtime 0.5, I think that I got introduced in. Maybe it was 0.6. But Netlify uses the API gateway proxy request and proxy response types for the incoming request and the outgoing response to GitHub. So we have to use those types for everything to match up and to deserialize from the JSON that's coming in into a Rust struct that we can use. This Lambda event splits our information into two different parts, the event and the context. We don't care about the context that contains like identity information and things like that, which we aren't using. So we'll get the event. The event comes in with all of the headers, all of the body text, and any other additional information that it might bring in for us. We then create a request client and set our webhook URL using an environment variable. This is set in the Netlify environment variables, so it will always be available when our function is running. And this is the location of the Discord webhook. So we match on the event.body. This event.body is a JSON string, maybe counterintuitively. It's a JSON string because, it really could be anything, and AWS doesn't know that. So we match on event.body, which is an option type on a string slice or a string. I think it's capital S string. Let's check. We can do that. Yeah, it's capital S string. So then we use our webhook type to turn that JSON string into the type that we care about, which really only has one field right here. So let's go up and look at the types. We've got this webhook type, which has repository inside, and then repository has a private, which is a Boolean, true or false. And I made it really small. I could have left this as a value, like a Saturday.json value instead, and that also would have worked. But I chose to type out just the things that I care about, and just leave everything else as whatever. We're just kind of throwing everything else away. So we check to see if the repository is private or not. If it is not private, or if it's public, then we send the request to Discord. So we continue, or we proxy through this request. We do that by setting the webhook URL to the Discord webhook. The Discord webhook, interestingly, has /GitHub on the end of the URL. So it's expecting data as sent from GitHub to come in, pass through all of the headers. So I've done no removal or addition of headers in this case. I just took the event.headers and I set them as the new headers, and we're off to the races. And then we pass in the body as is. So all we're doing here is saying if the repository is private, then don't send anything to Discord. If it's public, then send everything to Discord. And we can control what gets sent from the GitHub UI, which is kind of true. If we want to do any fine-grained filtering, we have to do it here. We have to use this builder API, which we've talked about over the last couple of days. .send gives us a future we can await. Then we can determine whether that was successful or not. We can get any text from the body back and await that and determine whether it was successful or not. And then we do nothing with the result. I just log it out. Realistically, there's going to be nothing we can do here, even if we get an error. The only thing that would happen if we got an error would be like somebody removed the Discord webhook. So we would notice that pretty quickly, but nothing would be sending. So I could set up some like logging or something there. We also should not receive anything that doesn't have a body. So I've just marked the none on the match for the body as unimplemented. So that will actually panic, but we expect it to never happen. So it is what it is. And then we return 200 OK with no body back to GitHub to say, hey, handled everything correctly. So if anything goes wrong, if something panics, the GitHub dashboard for webhook sends will let us know that it is not successfully delivering these webhook payloads. But the other way, if we send to Discord and it doesn't work, we don't really find out unless we're looking at the function logs. But that's it. It's just a small function. It's something that I needed today to do a job for a small thing. And that's it. So we get the organization level webhook that sends basically everything to our function. Our function takes it. If the repository is a public repository, then we send that or forward that request onto Discord's webhook receiver, which then puts it all out into the channel in Discord, which is wonderful. So now I get to show progress inside of Discord every time I put up a commit without having to ship everything from my private issues boards and private repos and stuff like that. So I hope you enjoy this. I hope this gave you some ideas for what you can do with some small serverless functions written in Rust. And I'll catch you in the next video. Have a great day.